Hello and welcome to this online training module on the Class LE and Class LC electrically held lighting contactors. First, let's review some basics on lighting contactors in general. Lighting contactors in industrial applications are primarily used to control power to large lighting and other non-inductive loads. They are not suitable for smaller consumer loads such as lights in your house, where those can be controlled from simple light switch. Rather, they are ideal for larger resistive loads, such as large bank of lighting, as might be found in a large office, an industrial plant, a store, or even a park, and so on. Lighting contactors are also ideal for multiple lighting circuits. One contactor can control multiple circuits simultaneously. There are several types of lighting loads. This training will only provide an overview of these loads. 480 volt tungsten is the first type of load our contactors can control. Tungsten is a common type of material that can even be found in the typical incandescent light found in most homes. Ballast loads are another type of lighting load. Siemens contactors are rated for up to 600 volt ballast. Any lights that use a gas, such as everyday fluorescent light, requires a ballast to excite the gas within the light. Lighting contactors can also be used up to 600 volt resistive heating applications. Resistive loads differ from typical inductive or motor loads in that there is no high inrush that you would normally see in an inductive load. Our lighting contactors are rated from 20 through 400 amps. A typical application in a large 400 amp lighting contactor could be, instead of controlling individual lighting circuits, you would use this contactor to control an entire distribution panel. So you would have the power going through the contactor and then feeding into the lighting panels. So when the contactor is energized, then it will allow power to flow through the entire lighting contactor. All the branch circuits will be energized. When the lighting contactor is off, it will kill the power to the lighting panel, thus all the branch circuits would be de-energized. Lighting contactors range from 2 to 12 poles and a variety of normally open and normally closed contact arrangements. A typical example of a normally closed lighting contactor could be an office that during the day you want all the lights on, but at night you may want the lights to be off, except for one night light so you can see in the room. This would be an example of a normally closed power pole, so that when all the other lights are de-energized, the night light will be energized. All of our contactors are listed as CUL-US. Now let's review the difference between electrically held and mechanically held lighting contactors. Electrically held contactor requires continuous power to keep the contact closed, so they operate just like a typical NEMA or IEC contactor, where the coil must be continuously energized. Once power is removed from the coil, then the contacts would open. Mechanically held contactors only require that the coil is momentarily energized, and then once the contacts are closed, the coil can be de-energized and the contacts are held closed either with a magnet or some mechanical device. With an electrically held contactor, if the control power is lost or if the coil fails, the contactor drops out. However, with mechanically held, even if the control power is lost or the coil fails, the contactor remains in its present state. So if something was to happen to the control power or something would happen to the coil and the contactor's contacts were closed, the contacts would remain closed because they are being held closed with a magnet or some mechanical device. Then to open them, a control signal would be sent to the coil to unlatch the contacts or to unpolarize the magnet. Electrically held, they are not recommended to be placed in quiet areas due to the coil being continuously energized and causing an inherent hum in the armature magnet. Mechanically held could be located physically in a quiet area since, again, they are not continuously energized. Electrically held consumes more energy to operate than mechanical styles. The electrically held is more economical and simpler device than mechanically held due to the additional functionality of holding the contact state. Some typical applications include schools, hospitals, office buildings, industrial plants, shopping centers, airports, stadiums, practically anywhere lighting is required. The Class LE is our electrically held lighting contactor. Some of the features and benefits include it is the most economical offering out of all of our contactors. It is used in applications where it is not critical that the contacts remain closed if control power is lost. Again, it is electrically held, and so you do lose control power, the contacts will open. The contacts are rated from 20 to 400 amps at 600 volts, and they come in 3 and 4 pole configurations. The 30 amp and the 60 amp contactors offer up to 12 pole configurations by using multiple 3 and 4 pole contactors all mounted on the same mounting plate with the coils daisy chained. Each individual contactor can have 3 or up to 4 poles only. Any additional poles will require additional contactors. They include a wide range of coil voltages ranging from 24 volts up to 600 volts, and they are offered in a full line of enclosures, including NEMA Type 1, 3R, painted 4, 4X stainless steel, and NEMA 12. The Class LE is available in either a non-combination or combination form, with either non-fusible disconnect, fusible disconnect, or circuit breaker. And they also include a full line of factory and field modifications from a selector switch, push button, pilot light, control relays, CPTs, and so on. This is a typical LE contactor. This one shown is a 20 amp contactor with 3 poles. And as you can see from the dimensions, it is very compact device which allows for smaller panels and more wiring room. Also, the Class LE are finger and back of hand safe and are also panel or DIN rail mountable. Some versions include a normally open auxiliary contact for use with a 3-wire control circuit. Externally mounted auxiliary contacts are also available and can be mounted either on top or on the side of the contactor. As far as accessories, again, it is a simple device. The auxiliary contacts, both normally open and normally closed, are included as accessories, plus all the existing accessories and factory modifications as previously discussed, such as push buttons, selector switches, and such. Replacement parts for the LE, such as contacts and replacement coils, are available, but only starting at 60 amps. Next, we will look at the Class LC electrically held contactor. It does have more features than the Class LE, thus it is more expensive. The contacts are rated up to 30 amps, 600 volts. Unlike the Class LE, where we have multiple sizes ranging from 20 amps up to 400 amps, the LC has only one size, which is a 30 amp contactor. One note is that for tungsten loads, its rating is only 20 amps. So it is always ideal to know the application, what type of lighting loads, tungsten, ballast, or some other type of load. The LC contactor can have up to 12 poles all on the same contactor, so you can range from 2 power poles up to 12, and out of those 12 you can have a maximum of 8 normally closed. You can have any combination of normally open and normally closed. Same range of coil voltages as with the LE, 24 volts through 600 volts. The Class LC can be ordered as either electrically held or mechanically held, or it can be converted in the field with a conversion kit. The same full line of enclosures as with the LE, NEMA Type 1, Type 3R, 4 painted, 4X stainless steel, and NEMA 12. Also the same full line of factory and field modifications as with the LE line. There are many features with the LC contactor. The first is that it has a contact position indicator. When the button protrudes, it means the contact is closed. As previously discussed, the LC has a conversion module, where you can take an electrically held contactor and mount the conversion module, and now you have a mechanically held contactor, which includes either 2 or 3 wire control. This will be demonstrated shortly. The LC also has plug-in auxiliary contacts, which are normally open when installed on the left side. If you take that same auxiliary contact and then you mount it over on the right side, now it becomes a normally closed. This innovative design allows you to use the same auxiliary contact, which you could consider in a neutral state, if you will, and that contact can be either normally open or normally closed. If you want that as a normally open, you would mount it on the left side. If you want it as a normally closed, you would mount it on the right side. And of course, you can have them both on the left and the right for a normally open and a normally closed. This flexibility allows the user to use one standard base contactor to be field expandable and flexible to future needs. On one base, you could start out with just 2 power poles, and then as your needs increase, you can add additional power poles out into the field until you max out at 12. Also, the power poles are convertible from normally open to normally closed and vice versa. This will also be demonstrated shortly. The LC has convenient side access field power wiring, and also, like the LE, the LC has finger and back of hand safe terminals. Now we will demonstrate the expandability of the LC contactor. Let's start with a 2-pole LC contactor and with the use of a simple screwdriver. You snap on the additional power poles, and within a few seconds you've added additional power poles up to 12 power poles. The power poles are convertible. As you can see on the left side of the base, you see the NO, which indicates normally open. And on the far right side, you see the letters NC, which indicate normally closed. That power pole that is installed in this example, looking at the top right-hand side, you see the letter NO. So that power pole is in the normally open. It is configured as a normally open power pole on the contactor. If we were to take that same power pole, remove it, rotate it 180 degrees, and then snap it back in the base, that same power pole would be configured now as a normally closed. You would be able to see the letters NC at the bottom, so similar to the auxiliary contacts, the power poles could be considered as neutral. It just depends on how you mount them onto the base. You can mount them as normally open or normally closed, and you could go back and forth as needed. Now the LC contactor is also convertible. The contactor, as shown, is the electrically held version, but it can be converted to mechanically held in 2 steps as follows. Step 1. We take the conversion module, which requires 2 screws, and then mount that onto the contactor. Step 2. We take the latch mechanism and install on the back of the contactor. Literally, within a few minutes, we have converted to a mechanically held contactor. And, should you need to, you can reverse it. You could remove the conversion module and remove the mechanical latch, and it will revert back to the electrically held contactor. As far as the accessories, we offer both single and 2-pole auxiliary contacts. The mechanically held conversion modules include both 2-wire and 3-wire control, with a variety of control voltages. The replacement parts include a single and 2-pole power pole module. And again, they are neutral. They will be either normally open or normally closed, depending on how you orient it to the base. Replacement coils are offered from 24 volts to 600 volts. One of the strengths of the LC contactor is it is so highly modular, it helps to greatly reduce inventory. So let's imagine that we stocked one base contactor and we stocked the 2 power pole kits, the single pole and double pole. We stock the 8 coil kits ranging from 24 volts up to 600 volts. And we stock the 6 conversion module kits, the 2-wire and the 3-wire control with the various voltages. With those 17 building blocks, we can assemble nearly 1,800 variations of open contactors. That doesn't include the auxiliary contacts or the enclosure kits to assemble the enclosed versions of the contactors. So it is highly modular, and that helps to greatly reduce inventory for channel partners. Again, as far as enclosures, we offer the non-combination type of enclosures. Same enclosures types that we use across the board for the Class LE, LC, and CLM. And they include short circuit ratings up to 100,000 amps. We also offer combination type enclosures. These are limited to the Class LE and CLM. We do not offer these combination types with the Class LC. A typical combination type lighting contactor includes a disconnect for lockout and maintenance, and it has short circuit ratings up to 100,000 amps, and they are UL rated as service entrance equipment. That means you can mount the enclosure on a power pole, and you could drop the power directly from the utility lines overhead into the controller. And they are ideal to control lighting in remote locations. Typical examples would include a baseball park, another park, remote parking lot, remote stretch of road. They include factory and field modifications. Typical mods such as control power transformers, pilot devices, whether it's a selector switch or a pilot light, control relays, control fuses, terminal blocks, time clocks, etc. Let's review with you now some general guidelines in selecting between the Class LE and LC. And again, these are general and not absolute. You may want to select the Class LE contactor if one or more of the following applies. If the required number of poles is 4 or less, the LE again is limited to 3 or 4 poles. So 4 or less poles, you may want to offer the LE because it is more economical. However, if the required current rating is greater than 30 amps, you have no choice but to offer the LE. If you recall, the Class LC, it is only one size, which is 30 amps, whereas the Class LE have sizes ranging from 20 amps up to 400 amps. If you need a combination type contactor in an enclosure, then you will have no choice but the LE. Again, we do not offer combination types of the Class LC. For the Class LC, you may want to select a Class LC if one or more of the following applies. If the required number of poles exceeds 4. When it exceeds 4, the Class LC starts to become more economical than several individual Class LE contactors. Again, the Class LC, you can have up to 12 poles all on the same contactor. You may want to select the Class LC if at least one normally closed contact is required. The LE only includes normally open contacts. They do not include any of the normally closed contacts. The LC, it can be a combination of normally open and normally closed. If additional power poles might later be added, you may want to select again the class LC. As we illustrated, it is very simple to snap on additional power poles onto the same contactor base. Or, if you might need a mechanically held lighting contactor, you might want to go with the class LC versus one of our conventional mechanically held contactors such as the class CLM. Now, speaking of mechanically held, you may want to consider the class LC in lieu of our CLM, whether it is a 20 amp contactor or a 30 amp CLM contactor. And of course, you may want to consider the LC over the competitor's mechanically held contactor. So again, the LC is very innovative. It can be used as either electrically held or mechanically held. The South Haven Distribution Center stocks all of the open contactors, but none of the enclosed contactors. This is basically the same strategy as our NEMA starters. The La Mirada Distribution Center may stock or make to order the more common open and enclosed contactors, albeit not all of them, but the more common ones. The West Chicago factory stocks or makes to order enclosed contactors. We hope and trust that everyone is familiar with the Controls Express program. If you are not, I encourage you to go to the DRC, the Distributor Resource Center, and take a look at the Controls Express brochure. It is a stocking program where now we stock enclosed NEMA starters, pump panels, enclosed soft starters, and now we've included lighting contactors. Again, South Haven already stocks all of the Class LE open contactors, and now they also stock several of the open LC contactors. If you look at the list, the first group of LC contactors are all open contactors, where South Haven will assemble them in 3-pole, 6-pole, 8, 10, and 12-pole configurations, and then stock them on the shelves. So you can get a completely assembled LC contactor in a variety of pole configurations stocked in the South Haven, and then also a couple of styles are stocked in La Mirada. The next group of contactors are the LC contactors in type 1 enclosures. Those include 3 through 12 poles, and those are all stocked in West Chicago, and a few are also stocked in La Mirada. The last group of contactors, those are the LE contactors in type 1 enclosures, and those are now stocked in West Chicago, and a few of the more common ones are also stocked in La Mirada. Again, if you're not familiar with the Controls Express program, go to the DRC and you'll find the brochure, not just for lighting contactors, but for other enclosed products as well. For sales and technical materials, you can find most of the information on the internet or the intranet on the lighting contactor webpage, and it includes the brochure, which is also available from the Xerox Literature Fulfillment Center. An overview for selling gives a brief summary of the family and its features. The supplemental catalog. The newer LE and LC contactors have not been added yet to the SpeedFacts or Industrial Controls catalogs. However, you can find the supplemental catalog for the new contactors. Also is a competitive comparison chart, a product guide form spec, the alphanumeric, data sheets, cut sheets, instruction sheets, outline diagrams, and wiring diagrams, as well as photos. In conclusion, we thank you for attending this online training class on lighting contactors and hope that this information has been useful.